Welcome again to yet another session where we're going to learn about mathematics. In today's topic, we're going to learn about addition and subtraction of fractions. Recapping from our previous lesson, we learned about the greatness of fraction in terms of the moving from the lowest to the highest in the rising of ascending, or in the move of ascending order, and then moving from the highest to the lowest in the move of descending order. However, today we're going to be talking about when two fractions are added or subtracted, what are the products you're going to get at the end of the day. Thus, we're having addition and subtraction of fractions. Let's begin. To the end of today's lesson, I believe you at home should be able to know all about the addition and subtraction of fraction in its entirety. So, an orange, let's take a look at this introduction for example. An orange is peeled and separated into 6 parts. So one orange separated into 6 parts in this form. Let's say this is the orange, separated into 6 parts. 1, 2, 3, 4, 5, 6. And there are 3 people that needs this orange. The first person there is Mr. Paul. And Mr. Paul received one orange, one part of this orange. A segment of this orange. Now each of these are all segments. They are all parts of a particular or a bigger whole. The whole there is the orange. The part is each segment or each segmented or cut out places whereby we can take chunks or parts from it. And you should always note that the parts is usually smaller than the whole. So Mr. Paul received one part out of the 6. Let's put it this way. Mr. Paul received this part. So this part is for Mr. Paul. And then Miss Jane receives 2 parts out of the 6. So again, this part and this part was what Miss Jane got at the end of the sharing exercise. And finally, Mr. Ben got 3 out of the 6 parts. 1, 2, and then 3. So these are all for Mr. Ben. 1 part, Mr. Paul. 2 parts, Miss Jane. And then 3 parts, Mr. Ben. Now if you look carefully, you will find out that the 3 of them have accumulated or consumed the 6 segmented parts that this particular orange was shared. Remember, it was shared into 6 equal parts. And when you look at what Mr. Ben got, he got 1, Miss Jane got 2, and Mr. Ben got 3. You add 1 plus 2 plus 3, you'll get the 6 parts. Now that's in the terms of the numerics. But in the terms of the arithmetics of this, and we are using the fraction, which has to do with the division. Out of the 6 in total, Mr. Paul has gotten 1 out of the 6. Now, another name for division is over, and another name for over is out of. So when we talk about division or fraction, we are talking about something out of a bigger thing. So in this case, in this sense, Mr. Paul got 1 out of 6, which is the total number of the parts that were divided from the one whole, which is the one orange. So the total number that was gotten from the division was 6. So Mr. Paul got 1 out of 6. Miss Jane got 2. So therefore, she got 2 out of 6. And then the final person was Mr. Ben. he got 3, he got 3 out of 6. Note, 1 over 6 represents 1 part out of 6, 2 over 6 represents 2 parts out of 6, and 3 over 6, pardon me, 3 over 6 represents 3 out of 6. You must always understand how to follow up the sharing formula so you don't make any mistakes, because you miss one number and you get the whole calculation wrong. This is where addition of fraction comes into play. Now, if we add 1 over 6 for Mr. Paul plus 2 over 6 for Miss Jane, and then 3 over 6 plus 3 over 6 for Mr. Ben. One of the things you will be seeing as we go forward is how to solve this particular problem. There are usually 2 ways you can do this, 2 particular ways. Before I enter those ways, let me first of all take the definition of fraction. A fraction is a small or tiny part, amount, or proportion of something. As I have said earlier, it is the result of dividing an integer by another integer. Means an integer that means a number by another number. Example, 1 over 6, 3 over 7, 4 over 11, even 0.25. Yes, it may be in the form of decimal, but in the case that we have 0.25, we usually use a term for it. It is called decimal fraction. It is called a decimal fraction. The number above each of the fractions is called the numerator, while the one below is called the denominator. These we are already familiar with, or we should be very familiar with. Fractions are used to describe situations in life, such as election results, percentage passed in an examination, percentage of a population infected by a certain disease or displaced by war, portion of a man's land handed to his son, etc. Now we have 3 major types of fraction. Now I actually pointed out the 4th one, which is the decimal. If you look below, you see the decimal. That one I've pointed already. That's the 4th one, but we do not count it that much because it is not part of the fraction mode in terms of it is not in the structure of the basic fraction system. So you have number 1 to be proper fractions. Now in proper fractions, you must understand that the numerator is less than the denominator. It's always less than the denominator. At no point should the denominator be lesser than, or rather should I say, at no point should the numerator be higher than the denominator in this case. So that's how you know it is a proper fraction. For example, 3 over 5. 3, which is the numerator, is lesser than 5, which is the denominator. Hence, a proper fraction. Now we have the second one to be improper fractions. Now these are fractions where the numerator is greater than the denominator. When you see the numerator is greater than the denominator, that is an improper fraction. For example, 7 over 4. 7 in this case is the numerator and is greater than 4, which is the denominator. And finally, we have mixed fractions. Pardon the error that was made there. It's not 53 over 8. Now, in mixed fractions, it is a compound, hence the word mixed. It's a compound kind of fraction. It's compound. The word we call compound is where 2 or more functions are coming together. Now, in this function, we have the whole number, which is the 5. What you're seeing on your screen is actually 5 whole number, 3 over 8. Now, we have the whole number, which is the 5. And then we have the fraction number, which is the 3 over 2. So when you bring both components together, you get 5 whole number, 3 over 2. Now, in mixed fractions, we always move to mixed fraction in the sense that we want to ensure that we reduce or we make the improper fraction a proper fraction. Now, if you look, apart from the whole number, which is a complete number, if you look at the fraction number, you'll find out that the numerator is less than the denominator, which is what we said at the case 1. Number 1 there in proper fraction, we say numerator is less than denominator. So that makes it a mixed fraction, and a mixed fraction in the sense that you're trying to reduce an improper fraction down is a proper fraction. Now let's get to the nitty-gritty of why we are here today, which is the addition and subtraction of fraction. First of all, let's start with the fractions that have the same denominator. Fractions with the same denominator. How do you solve it? Now, I will use, before I touch on the example on your screen, let me go back to my board and use this example I have from this one orange that we are segmented, or that was segmented into 6, and therefore shared into for 3 people in the ratio of 1:2:3. Now, if you look properly at your screen, you have 1/6 plus 2/6 plus 3/6. The common denominator there is 6, is the one that is going with everybody. So this, in this case, is so easy. You can just work with it in a very simplified way, in that sense. What it means is that the 6 will remain the way it is as your denominator, the one dividing everybody. And if you do 6 to divide everybody here, 6 divided by 6 will give you 1. 1 times 1 is 1. Plus 6 divided by 6 again will give you 1. 1 times 2 is 2. 6 divided by 6 will give you 1 again. 1 times 3 is 3. If you add all the numerator, everybody upstairs, you will get 6. And then you bring the one below, which is our downstairs, our 6. And then you have 6/6. When you divide this, it gives you a proof that what you indeed shared for all 3 persons was an orange. It will give you 1. So your final answer in this case is 1. If you look at your screen and where we have our example, we are asked to find you are asked to evaluate and simplify each of the following. The first one, they gave us 3/5 plus 1/5. Second one, they gave us 1/8 plus 3/8. Third one, they gave us 3/4 plus 1/4. And the fifth one, or rather the fourth one, they gave us 3/7 minus, the third one actually is a minus, please. Let me take that again. That's 3/4 minus 1/4. Then the fourth one is 3/7 minus 1/7. Now, the first thing you'll notice there in all of these questions is their denominator. And that's the fact that their denominators are all the same. I will say denominators with the same, fractions with the same denominator, you just bring down the denominator as a particular indices to use and solve the mathematical question. So in the sense that you're giving the number 1, let me clean this quickly. In the sense that you're giving the first question, they said (3/5) plus 1/5. First thing you notice there, we have 5 in both of them. So your denominator will be comprised of 5. As easy as that. Now, before I go further, take notes. There are a couple of ways by which you can look for your denominator to use there. Your common multiple. You can use the LCM method, or you can use the straightforward multiplication method. Now, I will show you both of them when I get to the next level, where we are having fractions with different denominators. But first things first, let me answer this question right now. Now, we have 5 here. 5 divided by 5 will give us 1. And 1 times 3 will give us 3. 5 again, divided by 5 1. 1 times 1 will give us 1. Therefore, if you add your numerators, the guys upstairs, you'll get 4, and then you bring down your denominator. Your answer to this question is 4 over 5. And this is a proper fraction. Because again, from our rule, or our case, in number 1, where we talked about the types of fractions, we talked about proper fraction being the fraction where the numerator is less than the denominator. In this case, 4 is less than 5. Thus, this is a proper fraction. Now, you can see that in that case, same case will happen with our number 2, but different from number 3. Now, number 2, now, if you are doing this again, you can actually use a different format. What is the format? Just put back your 8 in that number 2. Put back your 8 all over. Just do 1 plus 3. Now, if you just do 1 plus 3, that is your answer. Same with number 3 and number 4. Because the denominators are the same, just put by your denominator, put your division sign, that's your out of sign or your power sign, and then you just work on those upstairs, work on the numerators. 3 minus 1 will give you 2. 3 minus 1 will give you 2. Hence, you have 2 over 4 and you have 2 over 7 in the third and the fourth questions given. Please ensure you are very consistent in the way you solve it, because probably you're going to be in examination hall. You don't want to waste time to go through this long format. If you look at the question and you find the denominators are the same, apply this principle so you can save your time and get it done very, very fast. But be very careful so you don't make mistakes. Now, going to the next level, we have adding and subtracting fraction, or addition and subtraction of fractions that have different denominators. Now, this is where it gets trickier, or this is the most tricky part of this whole session. How do you add numbers, or rather fractions, that are of different denominations, or subtract in that matter? How do you work on those? Now, I'm going to show you the two methods how to work on these questions. But first of all, let's take notes. When the denominators are different, please ensure you use their lowest common multiple to evaluate, to solve the problem. The lowest common multiple is usually the product of the denominators. So you can see from this one note, you've seen the two aspects I want to touch on right now. From this one statement, the lowest common multiple, you might have deduced the two aspects I want to talk of. First of all, they say use the lowest common multiple, to evaluate the fractions. And the second part, they say the lowest common multiple is usually the product. Now, the word product there talks about the multiplication index. So multiplication is the product of the denominator. So let me highlight or solve the first and the second problems using the LCM method and also using the multiple or the product method. The first instance is, say, 3 over 4 plus 2 over 5. Now, in the LCM method, you come to do your LCM the way you usually do it. You put back your 4 and your 5, and then you use a common multiple that is lowest, at the lowest to the highest. The common multiple there to break down each of these numbers. Now, the first multiple that can go into this problem is 2, because we're having a 4 here. And 4 divided by 2, 4 divided by 2 is 2. But you can see that 2 cannot go into 5, or 2 cannot divide 5. Hence, you bring down your 5. This is your second level now, your second tier. You go again. 2 can go into 2, becomes 1, and 5 again will come down. Now, can 2 go again? Cannot go into. There's 1 and there's 5, and 2 cannot divide 5. Thus, 3 again cannot divide 5, 4 cannot divide 5. Now, the next number that is least enough to or that is low enough to divide 5 is 5 itself. So 5, we bring down a 1, and 5 will divide 1 to be 1. Thus, your lowest common multiple are 2 times 2 times 5. Or you can take it from up to down or down to up. So your answer is 2 times 2 is 4. 4 times 5 is 20. So therefore, your lowest common multiple here is 20. When you use 20 now to be divided by 4, or to go through what is given upstairs, 20 divided by 4 will give you 5. 5 times 3 will give you 15. You put back your plus. 20 divided by 5 is 4. 4 times 2 is 8. You now add, you put back your 20. And then you add your numerators. 15 plus 8 will give you 23. So 23 is your answer. Are we there yet? No. Why? If you notice carefully, 23 over 20, 23, which is the numerator, is greater than 20, the denominator. And if you look at your types again, or the rules under the types of fractions, you will notice that when the numerator is greater than the denominator, it is an improper fraction. Thus, we need to break this down to become a proper fraction. So we have 23 divided by 20. And if 20 divides 23, it will go 1 time, it will be remaining 3, and you put back your 20, which is the multiple that is dividing the integer or the numerator. The denominator dividing the numerator. Now you notice that this is having a whole number 1 and then a proper fraction 3 over 20. This is a mixed fraction, and this is your final answer. That's for the first aspect of using the lowest common multiple method. Now let's use the second. Let's go to our number 2, our example number 2, and let's see what we are going to get when we use the product method. Now, let me quickly erase this. Now, in the product method, we are only interested in the denominator. Let me just put that. Only the denominators. Please do not multiply the numerators, because you're looking for the number that can go and evaluate the fraction. And it usually comes from your denominator. So you're given 5 over 6 plus 2 over 3. The product method, please multiply the denominators. And in this case, our denominators are both 6 and 3. So 6 times 3, if you look at a multiplication table very well, 6 times 3 will give you 18. Therefore, 18 is the number we're using here. Now, I've seen some people that are using the comparative way of comparing. You want to compare. 6 can go into, or 3 rather can go into 6 and thereafter, so you can make it 6. If that will work for you better, you can use it. But here's the tricky things. There's a tricky fact about it. There are some questions that just using what can go between both of them may not work aright. And in that case, you might be confused. Better safe than sorry. So use the method of either the LCM or the multiple method. So in this case, I'm using 18. And if you use the LCM, let me just put this out there. You'll find out that you will get the exact same thing you got when you do your multiple method. Same thing. Now, okay, we have 18 now. So let me use, again, I can still use 6. It will work. But we are using 18 because we want to use the multiple method, not really the LCM method right now. Now, if you do 18 divided by 6, you'll get 3. 3 times 5 is 15. And because 3 is here to make the 18. 18 divided by 3 will give us the next number here, which is 6. 6 times 2 is 12. When you put back your denominator, when you add 15 plus 12, you get 27. Again, is this our final answer? Maybe, but not. Why? Because the numerator is greater than the denominator, and this is an improper fraction. Therefore, we have to make it a proper fraction. Now, 18 into 27 will go just one time, because 18 plus 18, which is the next 18 product, will be, we only go to, which is 2 times of 18, we go 36, it will be 36. Therefore, and 36 is greater than 27. Therefore, it can only go one time, which is one whole number. Then you look for what is the remainder, what is remaining there. When you do your long division, you will notice. But from my head, I know that 9 is remaining. One whole number, 9 over 18. Now here's the catch. And here's where the 6 come into play. 9 over 18, if I break this up, which is 1 and 9 over 18. Now, 1 here is my whole number, settled. But if you look at 9 over 18 is my proper fraction. Can it still be broken down? Yes, it can. 3 into 9 is 3, and 3 into 18 is 6. Therefore, also, 3 into 3 is 1, and 3 into 6 is 2. Therefore, my final answer will be one whole number, 1 over 2. Now, this question, if I use the LCM method, you're going to get the exact same thing. How? You use your 6. This is 1. Sorry, this is 1. 6 into 6 is 1. 1 times 5 is 5. 6 divided by 3 will be 2. 2 times 2 is 4. This will be 9. And this will be 6. And this will be one whole number. 6 can go into this will become one whole number, 3 over 6. And again, one whole number is definite number, but 3 over 6 is still a fraction number, and is a proper fraction number, but we can still break it down. 3 into 3 is 1, 3 into 6 is 2. Therefore, your answer is similar to this if you use the LCM method. Now, let's see the answers for these questions. Now, if you look carefully, these are the answers for the questions. The number 1, we've already done those one. We've already done the number 1. Sorry, that's not 13 over 20 in the solution, please. It's one whole number. One whole number. Okay, erased already. One whole number, 3 over 20. Then also the second one is one whole number, 1 over 2. Wherever you see the two numbers coming together, please, the first one is the whole number. In the case of number 3, it's 2 whole number, 5 over 12. In the case of number 4, which is the D, it's 5 over 12. That is the answer. Proper fraction, that's the final answer. The E, 27 over 56. Proper fraction, final answer. Then the 6, number 6, which is the F there, is 13 over 12, which is one whole number. Rather, it's not 13 over 12. One whole number, 3 over 12. That's the final answer. One whole number, 3 over 12. Please do not make the mistakes. Focus on the first digit or solve it yourself so you can get the accurate answer. All right, so these are the following questions you will have to attempt while you're at home for your evaluation, to ensure that you practice and get acquainted or get familiar with addition and subtraction of fractions. Now, if you notice in the first two questions, it was what was taught earlier on, or what was taught on earlier on when we talked about fractions with the same denominators. So be careful with it. Just play around it. You can search for more questions and you can try more questions. Just answer these questions and you will get quite good with addition and subtraction of fractions. Now take notes, please. The questions E and F, that's not 32 over 3, please, and that's not 21 over 5. That's 3 whole number 2 over 3 plus 2 whole number 1 over 5. So the last two questions are both mixed fractions, addition of mixed fractions, subtraction of mixed fractions. Please take note and don't make that mistake. Please, let's get some questions from past questions so we can get familiar or get to know what to expect when it comes to our examinations. Now, if we go to our 2021 past question, number 13 there, we have a question that says the additional of 8 whole number 1 over 4 to a certain number gives 10 whole number 1 over 2. Find the number. So they're asking us to find a number, an unknown number that can add with 8 whole number 1 over 4, 8 1/4, to get 10 and a half, 10 whole number 1 over 2. So let's work out that problem now together and see what is that number. They gave us a series of options there. So we have, so first things first, what I do or what we should do in this kind of situation is to make sure we represent the unknown. There's an unknown number we don't know. Then, to make sure we also showcase the total number. There is a total number there. What do I mean? We have the known number to be 1 over 4 that adds with a number, because they say the keyword there they use is additional. So there's addition there. Add with a certain number which is unknown. Let me call that number X. And they say the answer we got, or the result, was 10 whole number 1 over 2. In this case, if you look very carefully, you'll find out that we have already done, it's a bit of fraction and an algebra mixing together because there's an unknown number or unknown variable there. So if we take that into consideration, first off, to solve this kind of problem, there are two ways. You can choose to work with the fractions and remove the whole numbers, or you can choose to multiply through to use to get an improper fraction and then work your problem from there. Let me use the two scenarios and let me see if we're going to get the exact answer. So let me work with the removal of the whole numbers. Now in this case, this number is over here and is having an addition with him. I want him to go over here because he needs to meet like terms. We want to collect the like terms and keep them one place. We're collecting like terms now. So X will be equal to 10 1 over 2 minus addition going and over. Any number going over the equal to sign, the sign changes. In this case, addition will change to subtraction rather. That's how it works. Or if the case is subtraction, when it goes over the equal to sign, it changes to addition. So we have minus 8 whole number 1 over 4. Now, like I said, let me work with the whole number theorem first. Now, if I work with the whole number theorem, I will split it up. My whole numbers one side, and here, my fraction numbers the other side. Now, in this case, my whole number will be 2. In this case, using the LCM method, I have 4. 4 divided by 2 is 2. 2 times this is 2 minus. Is 4 into 4. 4 divided by 4 is 1. 1 times 1 is 1. And therefore, I have 1 over 4. So, by the time I bring back the whole number and the fraction number together again, my total answer will become 2 whole number 1 over 4. Now, this is the answer I got when I use the splitting method. But let me see what will happen when I do with the improper fraction method. Now, from the same place, from this place, X is equal to, I multiply through. 2 times 10, 20. 20 plus 1, 21 over 2 minus, you put by your minus sign, your subtraction sign, and then you do 4 times 8. When you do 4 multiply 8, you'll get 32. 32 times 1, 32 plus 1 is 33. So we have here 33 over 4. Then you find your common multiple there, which is 4. Your lowest is 4. 4 divided by 2 will give you 2. 2 times 21 is 42. 4 divided by 4 is 1. 1 times 33 is 33. When you do 42, subtract 33 from 42, you get 12. 12 minus, you borrow 1 here, this becomes 3, and this becomes rather 12. 12 minus this will give you 9. So your answer here is 9 over 4. Now you got an answer, but that's not a final step, because as we saw earlier on, when the numerator is greater than the denominator, is improper fraction. So we have to change this to a proper fraction. Therefore, we have 4 dividing 9 we go twice, 2 whole number, and there will be 1 remaining, 1, and then you put back your 4, the divisor, 1 over 4. You can see this answer and this answer are similar. Thus, your answer to that question in that particular year is D, 2 whole number, 1 over 4. Now, there's one more question we're going to answer before we end. Now, this one is more like a word problem. They say, or it is asked or demanded of us that we should find a boy needs 2.5 meters of clothes to make his uniform. How many meters of clothes will be needed for 5 boys using same measurement? Now, I am almost led to not do this particular question. Why? Because this is a question that should be reserved for next topic. Because it has to do with the multiplication and division of fractions. Now, we just did addition and subtraction. There's a multiplication and division of it. So we're going to skip this one till tomorrow, so we can till next time, so we can do this particular question where after we've seen all it takes in multiplication and division or subtraction. Till next time, take care and have a wonderful day.